Okay. Yesterday we solved trig equations on our, that were the special angles on our unit circle. Today we're going to be solving equations that might not necessarily be one of our special angles. So we call this solving trig. I'm just going to put equations with RAs, or reference angles. And I'll explain what a reference angle is in just a minute. Alright, so flip over to page 18. So an RA in this class is a reference angle. An RA is a reference angle. And a reference angle is an angle. I'm so sorry. Can you shut the door for me, please? In standard position. What does standard position mean? Wasn't that like the first week of school?
Oh, yeah, I don't know.
That is acute with the x-axis. So there are going to be 4 different scenarios with whenever we're using reference angles. So I'm going to draw 4 different graphs right here. And I'm going to have a terminal angle in quadrant 1. In quadrant 2, in quadrant 3, and in quadrant 4. So standard position is when you start at 0. Think of your unit circle starting at 0. On the x-axis and going around. So this is what theta is for each of these angles. You are writing this with me. You're not on your computer because your computer should be in test mode. You're going to need your computer, but it should be in Desmos test mode. Okay. Now, if I asked you for the inverse sine of 1/3, do you know where on your unit circle sine is 1/3? That's not one of the special ones we learned, right? So you do not know. Does there exist a sine of 1/3? Yes, there exists. But we don't know what it is because it's not one of the ones we learned. So you would use this method that I'm about to teach you to find out those angles. Okay? So the first thing I need you to know about reference angles is, in this case, for quadrant 1, your theta equals your reference angle. Because, your reference angle is an acute angle from the x-axis. So this right here is also your reference angle. Quadrant 1, theta equals reference angle. We love quadrant 1. Write it down. Quadrant 2, where would the acute angle from my x-axis be? It would be on this side, do y'all agree? This would be my reference angle here. What am I going to do to figure out theta using my reference angle? And although you're right, I want to use radians. So instead, what would I say? Pi minus your reference angle. For quadrant 2, you are going to do pi minus the reference angle. What about for quadrant 3? Where is my reference angle? The acute angle with the x-axis. Do y'all agree that's from right here to here? How would I find theta in quadrant 3 using the reference angle? Pi plus my reference angle, because it goes 180 and then adds on. So quadrant 2 is pi minus the reference angle. Quadrant 3 is pi plus the reference angle. Last but not least, my reference angle for quadrant 4, an acute angle, would be from there to there. So what am I going to do? It is 2 pi minus the reference angle for quadrant 4. You are going to need all of these memorized. I promise you, after notes today, you should have them pretty much down. Definitely after your homework, you'll have it down. Now, some things I want you to know about today's notes. We are going to be using Desmos today, which means you are going to get Desmos on the test. However, you will get your whole test wrong if it's not in radians. So calculator must be in radians, which is exactly why I told you to go into Desmos test mode right now. Because test mode's really nice, and once you put it in something, it'll stay there. Calculator must be in radians. The other thing is, most of your answers are going to be decimals, and I would like you to round to the 100th place. What does that mean? 2 decimals. 2 places after the decimals. Last but not least, I need you to know that a reference angle is always acute and always positive. Do you see how in the 3rd and 4th quadrant our reference angle goes down? That will be negative, right? However, when you're putting it in the calculator doesn't necessarily understand that. I want you to always only put a positive number in the calculator. And I'll show you what that means in a little bit. So your reference angle is just where the terminal angle is from the x-axis. It's just a value, but it's not necessarily the answer. Yep. So let's show you what I mean by all this and how we would apply all this. We're going to do 4 examples today. That's it. The sine of theta equals 0.3. Do y'all agree? Or what do I do next? inverse sine to both sides. Do y'all agree that is not one of our special values that we learned? No. If it is a special value we learned, you need to be giving me the radians, pi over something. But if it's not, we need to go to our reference angle. So, how can I find the reference angle? I can go to Desmos. And I can just type in the inverse sine of 0.3. You're going to need to go to functions. I can't see because of the thing. Inverse sine of 0.3. And what do I get as my answer? I cannot see because of that light, so can you tell me? Point what? 0.30. And actually, I'm going to go as far as call it, like, let's call this A equals. I just want to give it a value. I'm going to make it A. I think you could do RA, but I don't want to do two letters. Are y'all cool with that? Okay. Now, we have to figure out what quadrant we are dealing with here to know which one of these we are going to use. So let's remember about our quadrants. I'm going to kind of add this up here to the right. Just very small. What do we know about our quadrants? What do we know about quadrant 1? Positive, positive. Quadrant 2? Negative, positive. Quadrant 3? Negative, negative. And quadrant 4? Positive, negative. Okay, also you're going to need to know tan. Ava, write this down, please. Remember, tan is positive in 1 and 3. So that's just kind of my little note. Remember, slope is positive 1 and 3. Okay. So what do I have here? I have a sign that is, I have a positive sign value. Because I have a positive sign value, what two quadrants is that going to be in? Quadrant 1 and quadrant 2. Because quadrant 1 and quadrant 2 have positive sign values. And this is a positive sign value. Well, I'm going to write the formulas from above. For quadrant 1, theta equals RA. For quadrant 2, theta is pi minus RA. What's my RA? 0.3. And pi minus 0.30, thank you. Pi minus 0.30. And in your calculator, because I set it to A, you can just do pi minus A. If you don't set in anything, you have to copy it. And what do I get for that one? 2.84. Okay. So my answer here is 0.3 and 2.84. And don't forget to put it in solution sets. 0.30 and 2.84 is my answer. What questions can I answer for you?
Does it matter where I put the two solutions in the where I write it?
Like if you switch them around? No, it does not matter. Good question. What else? No other questions?
Oh, no.
Does everybody understand why we chose quadrant 1 and quadrant 2? Because it's a positive sign.
The answer is just wherever the function, like whatever the quadrant function.
Correct. Correct. All right, let's do example 2. Let's do the cosine of theta equals negative 0.42. What am I going to do here? Inverse cosine. Now, be careful. I'm going to write a little star next to this because I am not typing that in my calculator. What am I going to type in my calculator? I have to type in the positive 0.42 because my calculator doesn't understand this. By the way, somebody first period asked a really good question and y'all haven't. How come I am having to do all of these equations right here instead of just doing what my calculator gives me? No. Your calculator is only going to give you one value. For instance, if you ask what the inverse sine of 1/2 is, it gives you the decimal, but it's only going to give you pi over 6. It does not give you both values. Does that make sense? Because by the way, on all of these, we're on the interval of 0 to 2 pi. I forgot to say that. We're on an interval of 0 to 2 pi for all of these. So, just an FYI. Now, that's my RA. Put that in the calculator with a positive. Don't put the negative. What do you get when you put that in the calculator with a positive? 0.42. 1.14. That is your RA. Now, what quadrants am I in? Why 1 and 2? Ooh, not 1 and 2. Not 1 and 4. Go back to your theta, not your RA. What is my theta? A negative cosine. Where is cosine negative? Quadrant 2. Does everybody see how you can get confused on this? You're going to have to be very careful. You cannot put a negative in the calculator, but you also are using for your quadrants that original. Write your notes like I'm writing my notes so that when you go back and look at these later, you know where the heck I'm getting things from. Quadrant 2, what was the formula for theta? Quadrant 3, what was the formula? And then plug that in and get an answer. What do we get? 2.00. Please make sure you write both zeros. That lets me know you rounded and it wasn't a perfect answer. And 4.228. What questions can I answer? We will do reciprocals in a second. Any questions on 1 or 2? Do y'all want to try one on your own or not yet?
Yes.
Try one on your own? Okay. Let's try example 3. Go until you get stuck. All right. As I was walking around, most of y'all did this correctly, but what do you have to be careful when you get to this part right here? In the calculator, when you're doing your RA, you have to type in what? Positive 3, not negative 3. Okay? So when I type in the inverse tan of positive 3, what are you going to get? 1.25? I got 2.5. Y'all got 2.5? Okay, cool. Any questions about what I did from so far for this? All right, from here, what quadrants are we dealing with here? Go back to your theta. Your theta tells me I'm going to be a negative tan. Where's tangent negatives? Quadrant 2, quadrant 4. So theta is going to be pi minus RA. What's quadrant 4? We haven't done that one yet. 2 pi minus RA. Somebody asked me, Miss Olivares, do I have to show typing this in, like what I'm showing you right now? I need to see you plug in here or show the formula, one or the other. You can't just like give me answers. I need to see how you're getting these. So you don't need to write the formula out. If you want to go straight and write this out, I'm fine with that. Or you can just write this and give me the answer below. That's fine as well. But I need to see some form of work on how you're getting these solutions. So what is my solution? 1.89 and 5.03. Do I have any questions about this? Any questions? Example 4. The secant of theta equals 2.5. What am I going to do? Please don't ever put a reciprocal in the calculator. You don't need to. But you're right. What am I going to do? What's the reciprocal of secant? Okay, and I'm not going to write 1 over cosine. Are y'all okay with me just writing cosine? And if I just write cosine, what do? Flip the other one, and what's that? So both are right. You're right. It is 1 over 2.5. But some of you might be thinking, Ms. Olivares, 2.5 is just 5 over 2. Could you flip that and do 2/5? These are equivalent. That's right. That's fine. Okay, how do I get theta? Inverse cosine. Please make sure you're showing doing inverse to both sides. So theta equals the inverse cosine of 1 over 2.5. Or you could write 2/5, either one. What is my RA? Put that in the calculator. And I get 1.16. What quadrants are we dealing with here? Quadrant what? We're dealing with a positive cosine. Where is cosine positive? 1 and 4. And go off. What do you get? 5.12. Do I have any questions? Don't close your notebooks just yet. Do I need to show how I did anything in the calculator? We're okay? I see a couple people writing. I gotta tell y'all something. Y'all did not correct me yesterday, and I made a mistake in here. Y'all are usually good about correcting me, but y'all did not correct me. Can I change this? You're right, I am the teacher, but I still am human. I still make mistakes. Alright, can y'all go back to yesterday's page? Yesterday, I wrote out this whole long thing. Got to 7th period, and I was like, I don't think I wrote that in 6th period. And I went and looked, and I'm like, nope, I didn't. There was something wrong with this right here.
How am I supposed to correct you? I don't know this.
Well, what did we do? We were at pi over 3, and we kept going around the circle. When you go around a circle, what is that? Adding, how much? 2 pi. Y'all, we don't have any pi's in this. It was supposed to be 2k pi. I forgot the pi's. Well, it is on your homework tonight. There's only one problem. One problem on your homework. Alright. You just take what the answer is and then add 2k pi to it. Because you're adding the revolutions.
What about that k next to this?
It could be an n. It could be, that's just saying what the variable is. No. Just this one. Yep. Okay. You have the rest of the class. Do y'all want me to do a half angle example, or are we good for today? You sure? Okay. You have the rest of the class period. You can now, y'all look right here. Please make sure you are doing worksheet 1. You're on the worksheet 1 side. Worksheet 2, which is all quadratics, we're doing starting tomorrow. Yay.
But that's also due Monday?
No. Only worksheet 1 is due Monday evens. Due Monday evens. Okay? Don't worry about worksheet 2 until Tuesday. We'll have time in class to do that. So y'all have about 20-ish minutes to do the evens on a piece of notebook paper. Do not turn this in tomorrow. I will throw it in the trash. On a piece of notebook paper.
Evens are due tomorrow?
Evens are due Monday.